Hello students, this is Miss Dalton and this video is on aspect ratios. The definition of an aspect ratio is that it is the ratio of the longer side to the shorter side, or it's 1:1 if the rectangle is a square. Now, when we're going to be in this unit, we're going to be talking about some TVs, and so a TV is essentially a rectangle, right? But when we say a TV is 70 inches, so when you go to the store and you buy yourself a 70-inch TV, it's actually the diagonal that's 70 inches and not the length or the width. So we're going to take this into consideration when we're trying to find the length and the width of this TV. Some common aspect ratios are an 8.5 by 11 inch paper. It has an aspect ratio of 22:17. Now keep in mind that when we write our ratios, we don't really want to put fractions in it. And so when you say the aspect ratio would be the longest side to the shortest side, that would be 11 to 8.5. But because 8.5, we can't use that, then if you double both of those, then it would be 22:17. Now, if we simplify that, 22 divided by 17, that's going to give us the decimal 1.3. A 3 by 5 index card has an aspect ratio of 5:3. Notice that we took the longest side and we put it over the shortest side. So 5:3, and if you divide 5 by 3, you get 1.6 as your decimal. The aspect ratio for a 4 1/8 inch by 9.5 inch business envelope is 76:33, and that would simplify down to 2.3. So we're going to look at converting ratios into decimals, and then also taking the length and the width and writing it as an aspect ratio. So to convert, you're going to divide the first number by the second, and then you write it as a ratio to 1. So if I take 4 and I divide it by 3, you're going to get 1.3 repeating. So that 3 is going to go on forever. And so we would write that as just 1.3. Let's just round it to the nearest hundredth. So 1.33 to 1. So in decimal form, that's what it would be. Okay, and then if you look at example 2, 7 to 4, we're going to take the 7, we're going to divide it by 4. And so that's going to give you 1.75. So when we leave it in decimal format, it's going to be 1.75 to 1. Okay, if you have a ratio with fractions, to get the ratio into ratio form without fractions, the first thing you're going to do is make it an improper fraction. Each of the dimensions make it an improper fraction, and then get a common denominator, and then multiply by the common denominator. So let's take this example. So we have 5 and 1/6. So to convert it, we're going to do 6 times 5, and then plus 1. So that would be 31/6. That's how we convert it to an improper fraction. 3.5, 3 times 2, and then plus 1, so that would be 7, and put 7 over the denominator of 2. You're going to need to get a common denominator. Our common denominator is 6, so we're going to multiply this by 3 to get that to turn into a 6. So we're going to multiply that by 3, and so we would have 21/6. Now, if we take the longer dimension, which is 31/6, and we divide it by the shorter dimension, which is 21/6. Remember, when you're dividing fractions, you need to multiply by the reciprocal. So when I multiply by that reciprocal, that is the reason why we got a common denominator, because the denominators cancel. So in ratio form, this would be 31 to 21. Then as a decimal, when you divide that, you would type in 31 divided by 21, and that gives you, rounded to the nearest hundredth, that would be 1.48 to 1. Okay, so now let's work on this one. 2 1/3 would be the same thing as 7/3. 1 1/4 would be the same thing as 5/4. The common denominator of each of these would be 12. So to get this to turn into a 12, I'd have to multiply by 4. So that would be 28/12. To get 5/4 to change into a denominator of 12, I'd have to multiply by 3. So that would give you 15/12. Okay, so now if I take the larger one, 28/12, and divide it by 15/12, I can go ahead and multiply by the reciprocal, 12/15. The 12s cancel, so we get 28/15 as our aspect ratio. Okay, now write it in decimal form. So you're going to type in 28 divided by 15, and that comes out to be 1.87, rounded to the nearest hundredth, to 1. So when you divide, that becomes a ratio, which is called a unit rate, because it's to 1. All right, let's look at this example. It says, what are the dimensions of a 36-inch diagonal traditional 4:3 TV? So what that means is that we have this TV here, and the diagonal is 36. Now, sorry that that looks kind of slanted. I didn't mean for it to look slanted, so this should be a right angle. Well, if it's a 4:3 TV, then that means that the longest side has a multiple of 4. So we're going to say 4x. The shortest side has a multiple of 3x. But these are common factors because when we simplified it, that common factor got canceled out, and so that's how we get this ratio of 4:3. But that doesn't mean that the TV has a length of 4 and a width of 3. It just means it has a length of a multiple of 4. So that could be 8, 12, 16. It could be anything. We got to figure out which one, or what does the length and the width have to be to get a diagonal of 36. Well, this is going to take you back to geometry when you had Pythagorean theorem, right? And so for Pythagorean theorem, you take a squared plus b squared equals c squared. Well, c is always your diagonal, so that's going to be 36. And then we're going to square it. The a and the b are the other side, so we're going to have to take 4x and square it and add to it 3x squared. Now make sure you multiply that, you square the coefficient as well. So 4x squared is actually 16x squared. And 3x squared is 9x squared. 36 squared is 1,296. So if I'm solving for x, we need to find out what x is so that we can figure out the true dimensions of this TV. 16x squared plus 9x squared, that gives you 25x squared. And that equals 1,296. If I divide by 25, I get x squared equals 51.84. And then if I take the square root of that, you get x equals 7.2. So that means my length, since my length is 4x, I'm going to take 4 and multiply it by 7.2 that I just found. And so my length is actually 28.8 inches. Your width is 3x. So that's 3 times 7.2, which is 21.6. So my dimensions are length 28.8 and width 21.6. So you could say that's 28.8 by 21.6 inches. All right, last one says, what are the dimensions of a 65-inch diagonal 16:9 television? So we're going to draw just the right triangle. We don't need the whole rectangle. We know that the diagonal is 65, and we know that these dimensions are 16x by 9x. We've got to figure out what that common factor is of x. So we're going to use a squared plus b squared equals c squared. It's going to be very similar to the previous one, but we just have different dimensions. So we're going to have 16x that's going to get squared. We have 9x that's going to get squared. And then we have 65 squared. Well, 16x squared is 256x squared. 9x squared is 81x squared. And make sure you're squaring those numbers. That's a common mistake that I see, is when they don't square those numbers. 65 squared is 4,225. 256x squared plus 81x squared is 337x squared. If I divide both sides by 337, type that in on my calculator, and you get approximately, now I'm going to approximate it when I'm writing it down, but don't clear your calculator. Leave the whole number on your calculator. 12.5, I'm going to round that to a 4. Now, when you take the square root on your calculator, make sure you're taking the square root of the whole number. So I just go up and I hit the square root sign first, then I go up and grab that number and hit enter. Then that way you're taking the square root of the whole number and not one that has been rounded. So this comes out to be 3.54 if I round it to the nearest hundredth. So now I need to figure out my length of my TV. My length is 16 times the 3.54. And so that gives us 56.65. And the width is 9 times 3.54. And that comes out to be about 31.86. Both of these are inches. And so here are our dimensions. And you can put the little X there to show that they're dimensions. 56.65 by 31.86 would be the dimensions of this TV. And so you could, if you were having to hang this TV on a wall, you'd want to make sure that you have that much space to cover the length and the width. All right, in closing, you're going to work on these 4 problems for your assignment, and you're going to enter your answers in Moodle. But I also want to throw these thoughts out at you at the end here. Does it matter what order the numbers are written in when finding the aspect ratio of a rectangle? So I want you to think about that, and I want you to write it down in your notes. And then you've bought a 70-inch widescreen 16 by 9 TV. When mounted to a 5-foot wall, will it fit or will it hang over the sides? So I want you to take what you learned with Pythagorean theorem, and I want you to figure out if it will fit on that wall. All right, so hopefully this made sense. If you have any questions, please let me know.